I'm so sleepy.
Me too.
Yeah, well, I guess we should just finish this. Alright, so we've been talking about how the order that they want us to do stuff is kind of backwards, and it's like, oh, well, no big deal, because this, obviously they know what they're doing when they tell us what we're going to do stuff in, right? Okay, so I was talking to Mr. Schaefer, because he's the regular algebra teacher, right? And he says to me, well, the kids he has, they learned all this stuff in 7th grade, so we don't have to go over it again. I say, well, my kids weren't in 7th grade, so aren't we sort of out of luck? And he's like, well, I guess you'll just have to go back and teach it. And I said, well, okay. So here we are. Why does it say well so much? So I gave you slope intercept, and that was fun, except for that whole thing of if you have a variable on one side and you want to solve for it, well, we don't really have that much practice doing it, and now everyone's all confused. Which is good and bad. It's good because it's good that you're confused every once in a while because it encourages you to try harder. But it's bad because you're probably going to go home and cry and spend 3 hours working on it, even though we never really established how to do it. So that would explain why we're here now, to explain how to do it. So this is our problem 1. This isn't from any homework. This is just something I borrowed from a worksheet somewhere. And it says 5 times r plus 2 equals 17. And we want to know what is r, besides a pirate's second favorite letter. R. You know what a pirate's first favorite letter is?
No.
C.
Why?
Because the pirates are on the sea.
Oh, I get
Ha
it.
ha ha, pirate humor. Okay, so what am I doing? Oh, so we're solving for r. Problem with r is being multiplied by 5 and added by 2. This is completely different from our usual problems. That's something like, what's 2 times 5 plus 3 equals blank, where you just had to work it out on one side. This is all backwards. What we want is on this side with all these other numbers, which means we want to get rid of everything else partying with r. R wants to be antisocial for the day. So instead of using regular order of operations that says parentheses, exponents, multiply, divide, add, and subtract, which looks something like, please excuse my dear Aunt Sally, we're going to take that whole thing and we're going to work backwards, which means we're going to take our PEMDAS and we're going to group it all together. Oh, this seems so much better in my head. Okay, so we're going to take this and we're going to flip it upside down. Just like that. Okay? So anything we would have done first, we're going to do last. Anything we would have done last, we're going to do first. More specifically, since most of what you're going to see is going to look just like this, where it's usually a variable times a number plus or minus something else, we're always going to get rid of this plus or minus first because it's the first thing on our inverted PEMDAS. So we need to get rid of plus 2. So we need to do the opposite of adding 2. The opposite of adding 2 would be to subtract 2. Okay, we can do it to one side and that's great, but that messes up our equality. This needs to stay equal forever. So if we subtract 2 from one side, it means we need to do the exact same thing to the other side. Okay? So then we calculate from there. 2 minus 2 equals 0. This will always cancel out. The point of doing this is to cancel out everything except for this r. This is all part of the process of r being by itself. Okay? So we subtract 2 from one side, that cancels. 17 minus 2, that's 15. We can actually work that out. 5r hasn't been changed, so that gets to stay by itself. So our new equation, looking a little bit easier, is 5 times r equals 15. Most of you are probably sitting there saying, well, duh, I know the answer by now. That's not the point. Point is we need to continue down our list. So we've done adding and subtracting. So now we go to multiplying and dividing. So you see it's 5 times r. So we need to do the opposite of that. The opposite of multiplying by 5 is, of course, to divide by 5. So we're going to take both sides of this. Always, always, always. If you do it to the left side, you have to do it to the right side. They're equal. That's why we have these funny equal signs that you've been seeing since you were 5 years old. So 5 divided by 5 is 1. This cancels out. Oops, that's an Awful line. Please don't ever say 5 divided by 5 is 0. That's not how dividing works. This does equal 1. We don't need to write that though. 15 divided by 5 is 3. So we can say quite succinctly that R equals 3. We can check that. If we put 3 back in here, if we say what's 5 times 3 plus 2, guess what? It's 17. And that's it. There's your answer. That is how you work backwards in an equation. Okay? Okay? What did the pirate get on his report card? How many? 7 C's. Ah! Think about it. Number 2. Alright, same thing. Still upside down PEMDAS. We still want to get W by itself. W doesn't want friends anymore. So we have times -2. We also have -3. Remember, if we're doing upside down PEMDAS, I have to keep doing this every time. PEMDAS. And we're just going to flip it upside down. Dude, why does this not work? So slow. Okay. PEMDAS. Upside down. Let me copy this. Sugar. I hit the wrong button. Copy. Okay. So we start with the plus or minus. Because we need to get rid of this. How do we get rid of -3? We have to add 3. If we add 3 to one side to keep equality the same, we have to add 3 over here. So 25 plus 3 is 28. -3 plus 3 is nothing. We bring down the -2 W's. -2W equals 28. From here, we've done all the adding and subtracting. We go to multiplying and dividing. We have times -2. We don't want to do times -2. We want to do the opposite of that. The opposite of multiplying is to divide. So we divide both sides by -2. -2 divided by -2, still not 0, still 1. These cancel out. 28 divided by -2. Well, 28 divided by 2 is 14. Positive divided by a negative will always be negative. So -14 equals W. Or if you're I don't know what the word for it is, but if you don't like seeing it like that, you can put W equals -14. Perfectionist? I don't think that's the word I want, but whatever. That's not quite OCD either. OCD-ish. I don't think that's a word. We can check this if we say 25 should equal -2 times -14 minus 3. That's a lot of negatives. Wait, did I do that right? Yeah, okay, that's good. Okay, so -2 times -14 is 28 positive. 28 minus 3 is, you guessed it, 25. Yeah, whatever. Sarcastic claps from the peanut gallery. Alright, -3. -3, yes! It was question 3, now it's -3. So again, same thing. We start with the adding and subtracting. So we need to get y by itself. So we start by getting rid of +9. How do you get rid of +9? We subtract 9. Subtract 9 from both sides. Quality matters. Always, 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 always. -7 minus 9. They're both negative, so it becomes more negative after we combine them. So that's -16 equals 9 minus 9 is nothing. So all that's left is 4 times y. I don't know why people say my y's look like my 4's. Those are totally different things. So now we go to multiplying and dividing. How do we get rid of times positive 4? Hold on, this arrow is stupid. That's better. Alright, so we get rid of multiplying by 4 by dividing by 4. If we do it to one side, we do it to the other side, only not with a negative. Divide both sides by 4. Okay, 4 divided by 4 still doesn't equal 0. Still equals 1. It still goes away. -16 divided by 4 is negative 4. Negative divided by positive becomes negative. So negative 4 equals y. We can check it. We have negative 7 should equal 4 times negative 4 plus 9. Again, we just took the equation we just had and replaced y with the answer that we got for y. Alright? So 4 times negative 4 is negative 16 plus 9. Over here this equals negative 7. So we work this out. So negative 16 plus 9, guess what? Equals 7. Or negative 7 rather. Okay? So there you go. There are some examples of how to do it. We could do this all day, but it would get boring. Hopefully you get the point. If not, rewind it, watch it again. So now we have that, let's look at, quit clapping at me. I probably didn't mean to say that so aggressively, but it's too late to take it back now. So let's look at the homework, because that's the big deal, is we had homework on this. I'm going to erase this. If you wanted to see how to graph it, you should have watched the other video. Alright, so we wanted the X and Y intercepts for these lines. And we're going to see how what we just did totally is relevant to that. So I'm going to keep the line there because that'll give us an idea. Since here's our X and Y intercepts right there, we can see where the graph crosses the line. So that's a good way to check our answers. So if we want to find the X intercept, this is really the tricky one. We want to know where does it cross this line right here. Where does it cross the x-axis? So we know at the x-intercept that our y value is 0. All we need to know is what is x right there. Okay? So we take our equation. Y is negative 2. Oops. Y, I gotta go slow. Equals negative 2x plus 7. And we know that y equals 0. Because at the intercept it's got to be 0. So 0 equals, we don't know anything else. So negative 2x plus 7. And now you can see where those last three examples look totally like this. Because it's the same thing. So again, reverse PEMDAS. So we say we need to get rid of the plus 7 first. So we take 7 away. The opposite of adding is to subtract. If we do it to one side, we do it to the other side. So positive 7 minus 7 cancels out. Negative 2x is left over here. 0 minus 7 is just negative 7. Right? Second step is to divide. Because to get rid of multiplying, we have to do the opposite. The opposite of multiplying by negative 2 is to divide by negative 2. If we do it to one side, we have to do it to the other side. Hold on one second. Alright, so what did we say? So negative 2 divided by negative 2, that's going to cancel out. Negative 7 divided by negative 2. You could divide that and get a decimal. Or you could just, why not? Let's divide it. So 7 in, 2 out. We add a decimal here. This is going to give us 3.5 eventually. Right? Negative divided by a negative is going to turn this positive. So our x-intercept, where is it going to cross? Is it going to be at 3.5, and that's positive. If we look at our graph here, my line's not that great, but we do see it between 3 and 4, so this seems to make sense. Right? There's your x-intercept. So what about the y-intercept? That one is much easier. We talked about seeing the pattern with this. So the y-intercept, we know that our x value is going to be 0. We need to know what y is. Well, if x is 0, that means we're going to have y equals negative 2 times 0 plus 7. Well, 2 times 0 is just 0, so it's going to be 0 plus 7, when 0 plus 7 is just 7. So if we're in this form right here, if y is all by itself, x is being multiplied by its coefficient, plus or minus some number at the end, our y-intercept is just going to be that number. And parents watching at home, don't spoil what it's called. We're going to get there. It's okay. So our y-intercept is going to be positive 7. I'm just kidding, parents. You can spoil whatever you want. Have fun with math. Yay, fun. Alright, so that's that. So x-intercept 3.50, y-intercept 0.7. We can see both of those points here on the line we graphed. Okay? Let's find cursor. Okay. Let's take all that and make it a little bit easier to see. I said take all that and make it easier to see. Alright, very good. So let's bring this over. Let's look at the other side. So again, we need the x-intercept. So we know that x is going to be some number, y is going to be 0. So we take our equation, y is negative 3x minus 1. We will substitute y with our y value, which is 0. So 0 is going to equal negative 3 times some number minus 1. So we need to get x all by itself. So again, we start by getting rid of the plus or minus. So how do we get rid of minus 1? We have to add 1. We add 1 to one side, we have to add 1 to the other side. This is going to cancel out. 0 plus 1 is 1. Now we have 1 equals negative 3x. We want to get x by itself, which means we need to get rid of times 3. The only way to get rid of times 3 would be to do the opposite, which is to divide by 3. So we're going to have divided by 3 over there, divided by 3 over here. This is going to cancel out. This is a happy little fraction. This is just negative 1/3. So instead of having to turn that into a decimal and getting 0.3 repeating forever, we can just call this negative 1/3. And as long as we're here and they say, well, what if the negative's on the bottom, what if it's on top, what if, who cares? If you have this number here, or this number here, or this number here, all these numbers mean the exact same thing. If you have one negative either in the numerator, the denominator, or outside the entire fraction, it means that whole fraction is negative. Okay? So negative 1/3, 0, we can kind of see that here. Kind of. My line's not that great. Yeah, it should be like right about there. So my line needs a little bit of fixing. Oh well. There it is. How about that? Alright, our y-intercepts. Much more straightforward, much easier to find. If x is 0, what is y? So we say y equals negative 3, x is going to be 0, minus 1. 3 times 0, or negative 3, well, whatever times 0 is going to be 0. 0 minus 1, well, it's just negative 1. So our y-intercept is going to be 0, positive 1. Wait, negative 1, negative 1. Oh, whoops, I almost messed that up. Negative 1, and there we can see it right there. So there's our x-intercept and our y-intercept. We will go over more of this tomorrow, so if you still don't get it, that's okay. We're going to get it eventually, hopefully, right? Okay, good night.